Hello guys, good evening everyone. Welcome to the session. Welcome back to the India's most comprehensive preparation platform, that is the BYJU'S exam prep. A very good evening everyone. Good evening Monisha, Tushar, very good evening all, and quickly share the session. Update your friends that the session is live, and in this session of electromagnetic theory, we are going to discuss the concept of the oblique incidence of electromagnetic waves. Yes, when a wave traveling in one medium travels into another medium and it strikes the boundary. There are two cases. One is striking normal to the boundary, and another case is striking at an oblique and at some oblique angle with respect to normal to the boundary. Now, if I talk about the normal to the boundary case, that is very important. Many of the students are able to handle it easily because that's mostly formula based. Okay, but this is the topic which has a little good geometrical approach, good understanding. So you need to understand it, and that is why in this session I'm going to talk dedicatedly about how to approach the oblique incidence cases, right? How much of the energy is reflected back, how much of the energy is transmitted back, what are the reflection and transmission coefficient formula under the S polarization and P polarization. Very good evening everyone. Come on quickly, everybody join up the session. Yes, hi all, good evening. All right, chalo. So guys, let's begin up. Let's start up. Yes, in case somebody new to my session, this is a brief intro about me. I am Rakesh. I've secured All India rank 9th in GATE, completed my Masters from Indian Institute of Science, and these are my major area of expertise, dealing with more than 12 years now, right? And yes, guys, a very important update. The BYJU'S exam prep brings you a free mega important workshop. Yes, primarily students focuses the GATE for MTech as well as PSUs. But you know, there are not only MTech and PSUs, there are several other key prospects. See, if I talk about career opportunities through GATE, it can be many, but there are 7 key career prospects through the GATE 24 examination. What are them? To know, join live on 18th December at 12:30 p.m. This Sunday, 18th December at 12:30 p.m. with me on the BYJU'S exam prep app. This is on the BYJU'S exam prep app, right? Okay, and also guys, as I just told you yesterday as well, yes, on the same YouTube channel where you are watching this session. So in case you have not subscribed, do not forget to subscribe so that you get all these updates, all these sessions. The GATE PYQ series, yes, in the live subject-wise questions, discussion manner. Yes, all those having any doubts or PYQs, and we know the recent 5 years question will give you a better idea ki how the level of GATE is going, what type of topics they are more focusing, where the technology is going, and where you have to focus more. That is why we are bringing a live subject-wise question discussion on the YouTube on the same channel. We'll cover up the questions of 2018, 19, 20, 21, 22 for the EE, ECE and the IN branches. Do not forget to subscribe now to attend the series, and that starts from 18th of December, again Sunday, right? Okay, so BYJU'S exam prep brings you the mega mock as well. Yes, it's the December, and you should definitely be very serious about the mock test. And BYJU'S exam prep also gives you an opportunity to appear in the mock test, and that is actually free. This one is free, mega mock challenge, All India Open mega mock test for GATE 2023. It has started from yesterday, 13th December, and it is going to be live up to the 20th of December. You can appear at any time at your convenience, right? This is again on the BYJU'S exam prep app. Go to the app and register for this mega mock and appear and see your performance, right? Yes, communication in the crash course is coming up next week probably. It's going to come up. I think after EMT it's communication only, dreamer. Just don't worry, okay? Chalo guys, so let's get started with the oblique incidence quickly. Now, as I was giving you the brief in that, yes, when a wave traveling in a certain medium. Now let's understand this picture first of all. Let's understand this whole picture first of all. Okay, so I have a boundary which I'm assuming, see, there can be any boundary, but let's have a reference to understand this. Suppose there is a boundary at z equal to 0. Now z equal to 0 is also known as the xy plane, right? XY plane. And for reference, I have taken this as x-axis, and let's say this is the finger Okay, this direction pointing out of the screen, this direction pointing out of this board is the y direction. So this is what is my xy plane, right? This is what is my xy plane, right? And if this is what is my xy plane, I take this as the z direction. Okay, z cross x will be y perfectly. Y is outside of the screen. So this is my xy plane. So what you have to simply assume is, if this is the xy plane, z equal to 0, on the left side of this, on one side of this, we have a medium characterized by the parameters of sigma 1, epsilon 1, mu 1. That means conductivity sigma 1, permittivity mu 1, and magnetic permeability mu 1. Permittivity epsilon 1, sorry. Right? As soon as I go to the other side, I have another medium which has the property sigma 2, epsilon 2 and mu 2. Sigma 2, epsilon 2 and mu 2. A wave is traveling and it strikes the boundary at some angle of incidence. I'll give you the definitions also. Angle of incidence, angle of reflection and all those things. Okay, we'll give you the official definitions also. All these angles are measured with respect to normal to the boundary. Now, what is the boundary? The boundary is xy plane. So what is a vector perpendicular and normal to it? What is a vector normal to xy plane? Is a z direction. So when I talk about z direction, this is also a vector. This is the boundary and this is a vector perpendicular normal to the boundary. This is a vector normal to the boundary and this is also known as the normal direction. Simply the normal direction. Right. And all the angles are going to be measured with respect to normal. So this is the normal line. With respect to normal only I measure the angle of incidence. With respect to normal I measure the angle of reflection and etc. Okay, and etc. But here guys, one important point. Before I define the angle of incidence or angle of reflection or angle of transmission, anything if I define, right? Anything if I define, okay, you will not be clear unless and until I give you one important condition. So before we go to the angles, understand one important condition here. Normally guys, students represent the electric field equation. Suppose that the wave, everybody listen to me, important point. Okay, just suppose a wave which is traveling, a quick review karenge, a wave traveling in the plus z direction. Suppose there is a wave traveling in the plus z direction. So if there is a wave traveling in the plus z direction, how do you write down its electric field? Right. We first of all call this as DOP, direction of propagation, represented as AK, and that is known as AZ here. DOP, please note down, it is known as the direction of propagation. DOP is known as the direction of propagation. ठीक है, बहुत बढ़िया. Right. How do I write down its electric field? Electric field in the phasor form is written by the formula E naught e raised to the power minus gamma Z. E naught e raised to the power minus gamma Z. And in the time varying form, it is written as E naught e raised to the power minus alpha Z cosine of omega t minus beta Z. All this has been obtained by solving the Maxwell's equation, right? Let's focus on oblique incidence because there is so much in the plane waves. Okay, not everything about plane waves, but very important oblique incidence, because most of the things about plane waves, whether it is normal incidence or basic property of wave, it is very simple. Many students can handle. Oblique incidence focus karna hai, right? So these are the equation of waves. Yeah, if I talk about lossless medium, actually, if I talk about lossless mediums, let me tell you, for lossless mediums, there is no attenuation. Alpha is known as the 0. Alpha is known as the 0 and gamma is given by J beta. Alpha is known as 0, gamma is given by J beta, and then the ES is given by the formula E naught e raised to the power minus J beta Z, and E is given by the formula E naught, alpha 0 hai. So directly the cosine of omega t minus beta Z. These are the equations that you are used to with maybe, right? Now listen to me. This is about the wave traveling in Z direction. But here, if the wave travels in the Z direction in our picture, if the wave in our picture travels in the Z direction, that means it is traveling normal to the boundary. Then it becomes the normal incidence case. Then it becomes the normal incidence case, right? So if the wave is traveling in the Z direction, okay, this is going to become the case of normal incidence here. Right. See, normal incidence is a different story, right? Right. If you guys want, you can let me know. We can have a separate session, right? But मैंने oblique को prefer किया because normal is very important, very easy. Usually students are able to deal with that. Okay. And many of the cases and formula of normal incidence are repeated in transmission line. वो भी हम देख लेंगे. Tomorrow we have the transmission line session anyways. Okay, so suppose there is a wave traveling in the plus Z direction, then it becomes a normal incidence, but that doesn't become the oblique incidence. That means if the wave has to travel at the oblique incidence, if the wave has to strike at an oblique incidence, it is going to be travel. If I just assume the same picture, it is going to be travel in a direction which is combination of x, which can be resolved in x and which can be resolved in z. It is traveling in a direction which is combination of x and z. It is traveling in a direction which is known as the combination of the x and z. Yeah, in this picture x and z, it may be x or y, or it may be x, y, z. It can be traveling in any general direction. First of all, dear, how do you write down for a wave traveling in any direction? For a wave traveling in any direction, we define the equation as E naught e power minus j k dot r, or in the time varying form, we define E naught cos omega t minus k dot r, where r is known as the general position vector, which we write as x ax plus y ay plus z az. The k here is known as the propagation direction. The k, the vector k, will define here the propagation direction, and the k is known as the propagation vector of the wave. The k here is known as the propagation vector of the wave, right? The k here is known as the propagation vector of the wave. So, sir, what is the propagation vector of this wave? Everybody listen. Sir, what is the propagation vector of the wave? We call, I am telling you, a wave can be traveling in any direction. Here x or z. In general, x, y, z or y, z, anything can happen in other situation. So, in general, we write down the propagation direction as kx ax plus ky az, ky ay plus kz az, assuming that it will have some x component also, some y component also, and maybe some z component also. Right. Now, when you take the k dot r, very simple calculation, na? K is the kx ax plus ky ay plus kz az. Dot product with the x ax. R vector is x ax, y ay, z az. Right. When I take the dot product of this, I get the kxx, kyy and kzz. So my equation becomes E naught e power minus j kxx, kyy, kzz, or in the time varying form it is E naught cos omega t minus kxx minus kyy minus kzz. You should always note that the modulus of k will be equal to the beta, and for lossless mediums, beta is omega root over mu epsilon. Now, before I take up any oblique incidence case, I want you to, and this is how, see, magnetic field formula is same as you have studied earlier also, there's no much difference, right? So, HS will be written as AK cross ES divided by AK eta. AK is the unit vector along the direction of K. How do you calculate unit vector? Vector K divided by its magnitude. Vector K divided by its magnitude. Okay. Now, just let me know this answer. This is not directly oblique incidence question, but you need to be familiar with this technique. See, suppose there is a wave traveling, okay, whose electric field component is given to you. There is a wave with some electric field component given to you. Okay, with some electric field component, 100 e power minus j 0.866y plus 0.5z. What is the propagation vector of the wave? That is the important question. What is the propagation vector of the wave? 100 e raised to the power minus j 0.866y plus 0.5z ax. Tell me, what is the propagation vector? So we know this has to be kyy plus kzz, right? So just by comparing, I can tell you that this is the y component of the propagation vector, this is the z component of the propagation vector, and there is no x component. Very clearly, there is no x component. So what is the vector k? So dear, what should be the vector k? Vector k is 0.866y plus 0.5z. 0.866y plus 0.5z. Okay. Now this you must everybody be able to extract, given the electric field general equation. What is the direction of wave traveling in any random direction? This is a wave traveling in the combination of y and z direction. Oh, sorry. I should actually write down, this is the vector. This is 0.866 ay plus the 0.5 az. This is the vector having the y component and having the z component given to us. Having the y component and the z component given to us. Okay, badhiya. Right. Now, if this is clear to you, now I can go forward and talk about the oblique incidence case. Now I can go forward and talk about the oblique incidence case, right? Yes. Let us come back to this oblique incidence case. Okay, once again have a look into the picture. Z less than 0 is some medium 1. Z less than 0 is some medium 2. Okay, medium 1 has the property sigma 1, epsilon and mu 1. Medium 2 has some parameters sigma 2, epsilon 2, mu 2. Conductivity, permittivity and permeability here, right? This is the boundary which is again Z equal to 0 here. There is the boundary which I have again assumed to be Z equal to 0, and Z equal to 0, as I told you, is known as the XY plane. Z equal to 0 is known as the XY plane, right? So if this is the X axis, let's say this is the Y axis. Anyway, Z cross X is Y outwards of the screen. This is the XY plane, right? Left side of this is region number 1 and right side of this is region number 2. Okay. The boundary is XY plane. So what is the vector normal to it? If the boundary is XY plane, what is the vector normal to the XY plane? The vector normal to the XY plane is in the Z direction. So this vector, this Z direction will be known as normal to the boundary. Now everybody, please look into angle of incidence. Plane of incidence हम question में बना लेंगे, don't worry. Right? Angle of incidence. It is the angle between the propagation. K is the propagation vector, Ki. Propagation vector of incident wave and the normal to the boundary, right? Propagation vector of the incident wave, what does angle does it make with respect to normal? This is the normal line. That angle is known as the angle of incidence. Right? Then, angle of reflection. The angle that the reflected wave makes between with the normal to the boundary. So this is the reflected wave. What is the angle that it makes with respect to normal to the boundary is the angle of reflection, right? And similarly, we have the angle of transmission. What is the angle that the transmitted wave, that the wave is going to transmit in the medium number 2? What is the angle that the transmitted wave makes with the normal to the boundary? That is known as the theta t. Right? Now, every medium, okay, what is the relation between these two depending on every medium? Whatever may be the medium, guys, basic law of optics say that the angle of reflection is always equal to angle of incidence. Okay, there will be simple two relations coming up here. Okay, the theta r, the angle of reflection is always equal to the angle of incidence, number 1. Right. What about the angle of transmission? How to calculate the angle of transmission? To calculate angle of transmission, we apply the Snell's law. N1 sin theta 1, or that is N1 sin theta I, is equal to the N2 sin theta t. And this is what is known as the Snell's law. N1 sin theta I is equal to N2 sin theta t, where what is N here? Where what is the N? N here means the refractive index. N here is known as the refractive index of the medium, right? N is known as the refractive. Yes, these relations are again given here. Theta r is theta I and Snell's law is given to you. Okay, and N is the refractive index. The basic definition of refractive index is it is the speed of wave in free space divided by the speed of wave in that particular medium. It is the speed of wave in free space divided by the speed of wave in that particular medium. Speed of wave in free space divided by speed of wave in that particular medium. ठीक है? अच्छा. Right. So it is equal to speed of wave in free space is always c divided by speed of wave in any medium, in any lossless medium is 1 upon root mu epsilon. So n is equal to c root mu epsilon. Now there are different formulas of it. Okay. N is either c by u. U is the speed of wave in that particular medium. Right. Or this is equal to c root over mu epsilon. Right. Or if you write down c, c is given by the formula 1 upon under root mu naught epsilon naught, and mu epsilon can be written as mu r mu naught, epsilon r epsilon naught. After all calculation, mu naught epsilon naught will cancel and it is equal to root over of mu r epsilon r. This is also one of the formula. Right. It is the geometric mean of relative permeability and relative permittivity of the medium. So there are 2 or 3 different formulas that you can use for the refractive index. So this Snell's law and along with that basic law of optics will tell you what is the relation between the angle. What is the angle of incidence? अब ये कैसे निकालेंगे? Theta r will be theta I. Once you know theta I, you can calculate theta t by the Snell's law. But what is theta I? Now either theta I can be given to you or you can calculate theta I by Suppose what can happen, like one of the question I've shown you earlier, given the equation of electric field of the wave. From that equation of the electric field of the wave, what can you calculate? From that equation of the electric field of wave, you can calculate the propagation vector. Now, let me write down, this is known as the propagation vector Ki of the incident wave. Okay, this is the direction in which the incident wave is traveling. This is the direction in which the reflected wave is traveling, Kr. And this is the direction in which the transmitted wave is traveling. So, what you can do here is, okay, suppose electric field equation is given, you can calculate Ki, just I have shown you in the question. And ek bar Ki aa gaya, what is theta I? It is the angle between Ki and Az. Oh yeah, An, in general, whatever is the normal. How do you calculate angle between? How do you calculate angle between any two vectors? How do you calculate angle between any two vectors? By the formula of cos theta, which is A dot B upon mod A mod B, by the dot product concept. Right, cos theta I, it is the angle between Ki and An cap. So Ki dot An cap divided by mod Ki and mod An cap. But An is a unit vector. So modulus of unit vector will be 1. So simply you can write down only modulus of Ki. Right. This is how you can figure out the angle of incidence. A dot B upon mod A mod B. Right, A dot B upon mod A mod B, the dot product basic formula has been applied. A dot B is given by mod A mod B cos theta. Okay, now all this to be applied in the problems and then we will understand. Okay, so now we can obtain the angle of incidence, angle of reflection, angle of transmission, everything. Okay, but what is the equation of reflected electric field? For that we need what? For that, always we need the reflection coefficient and the transmission coefficient. So dear, what is the reflection and the transmission coefficient? Okay, the basic definition of reflection and transmission coefficient. The reflection coefficient known as the K is basically equal to the amplitude of reflected electric field, suppose ER naught, divided by the amplitude of incident electric field, suppose EI naught. It is equal to ER naught divided by EI naught. And what is the tau? Transmission coefficient known as the tau, it is basically the magnitude of transmitted electric field to that of the incident electric field. ET naught is divided by EI naught. K is equal to ER naught upon EI naught and tau is equal to ET naught is divided by the EI naught. Correct? Acha. Right. Okay. So, the formula of reflection and transmission coefficient will depend on the type of polarization of the wave, and as we all know, polarization depends on the orientation of electric field. Here what orientation I am talking? If the electric field is parallel to the plane of incidence, iska matlab kya hoga? If I look into the same picture, here what is my plane of incidence? Now everybody understand. What is the plane of incidence? What is the plane that I have drawn in front of you? That is the XZ plane. So my plane of incidence here is XZ plane, the plane in which the entire story is going on. Right? So plane of incidence is XZ plane. Now dear, suppose that plane of incidence is XZ plane. Suppose that the electric field is also in the X direction. Suppose that the electric field is also in the X direction, or electric field is in the Z direction, or a combination of XZ direction. That means electric field is parallel to the plane of incidence. It is within the plane of incidence. Also, we can call it is the parallel to the plane of incidence. So when electric field is in the plane of incidence or parallel to the plane of incidence, that is the parallel polarization. But dear, suppose that the electric field is along the Y direction. Just assume. Suppose the electric field is given to you in the Y direction. Okay. So Y is perpendicular to this plane of incidence. Y is perpendicular to the plane of incidence, and that polarization will be named as perpendicular, or also known as S polarization. That polarization will be the perpendicular polarization, or known as the S polarization. That is known as the perpendicular polarization or the S polarization. Perpendicular polarization or the S polarization. Done? Okay, so as I am telling you, the formula for reflection and transmission coefficient will depend whether it is the parallel polarization or perpendicular polarization, right? Parallel polarization, the formula for K will be, this will set with practice, don't worry, eta 2 cos theta t. Now what is eta? Eta is not the refractive index, that is N. Eta is the intrinsic impedance of the medium. Eta is the intrinsic impedance of any medium. Let us recall all the terms. Whatever required for revision, we will recall it. Eta is known as the intrinsic impedance of the medium, and that is given by the formula. Eta is given by the formula root over of j omega mu is divided by the sigma plus j omega epsilon. And if it is a lossless medium, if it is a lossless medium, then eta is simply given by the formula root over mu by epsilon. For lossless medium, it is simply root over mu by epsilon. Okay. So K is given by the formula K parallel. We can also call it as Kp, right? Eta 2 cos theta t minus eta 1 cos theta I divided by eta 2 cos theta t plus eta 1 cos theta I, and the tau parallel, also known as tau p, is given by the formula 2 eta 2 cos theta I. Theta t nahi hai, 2 eta 2 cos theta I upon eta 2 cos theta t plus eta 1 cos theta I. But please remember, 1 plus k is not equal to tau. This is usually true in normal incidence. That is why I am highlighting this point. 1 plus k is not equal to the tau, right? Similarly, if we go to the S polarization, as I already explained you, when electric field is perpendicular to the plane of incidence, that is the S polarization, perpendicular polarization. And have a look into this formula. Allow me just 2 minutes. Dear, just allow me 2 minutes. I shall be back. Yes, guys. Yeah. Let's come back. Okay. So, as I already told you, suppose plane of incidence as our example. Plane of incidence is xz, but electric field is in the y direction. Then it is perpendicular to the plane of incidence, known as the S polarization. And for that case, the K is given by the formula eta 2 cos theta t, K, also known as the Ks. Eta 2 cos theta I minus eta 1 cos theta t divided by eta 2 cos theta I plus eta 1 cos theta t, and tau perpendicular or tau S is given by the formula 2 eta 2 cos theta I upon eta 2 cos theta I plus eta 1 cos theta t. And here you can note down 1 plus k equal to tau. That means only remember the formula for k, and 1 plus k is tau. No need to extra put down the formula for tau, right? No need to extra put down the only remember the formula for k. It was all good before I stopped. Just that 2 minutes break, I think, has distorted the voices. Let me check that again. Sometimes it may be a little bit distortion. It will get all right. Don't worry, है ना? It's not a very big problem to worry about. चलो, okay, ध्यान दे रहे, right? Okay. Now, guys, whether you talk about a perpendicular polarization or ध्यान दे रहे, right? Okay. Now, guys, whether you talk about a perpendicular polarization, there is still some distortion here. Hello, 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 hello. Yeah. little distortion is there. I think it will get rectified automatically. Sometimes it goes away. If it doesn't go away within a minute or so, we'll try to rectify it in another way. Okay, now whether you talk about the perpendicular polarization or the p polarization, okay, have a look into the formula for reflection coefficient. Reflection coefficient is in the numerator, there is a subtraction term eta 2 cos theta I minus eta 1 cos theta t, right? It may be possible that if you choose the proper angle of incidence and transmission, you can only choose the angle of incidence, transmission angle will automatically follow by the Snell's law. So suppose you choose a proper angle of incidence such that eta 2 cos theta t minus eta 1 cos theta I results to be 0. Then what is the conclusion here? Such that the k becomes 0, and if the k becomes 0, I will say that there is no component of the wave which is reflected back. 0. And there is no component of the wave that is reflected back, and the wave is only propagating. The information is not lost, right? You have transmitted an information, it met a boundary, it met a discontinuity, right? A portion of it usually reflects back, bounces back, and a specific portion only is propagated forward. But if you ensure that k is equal to 0, then there is no reflected back, and whatever wave you have transmitted, whatever wave you have sent, it's going to be transmitted forward fully without any loss, without any reflection. That is what we actually ideally want. And this will be possible if you ensure that k will be equal to 0. If you ensure that k is equal to 0, right? That special angle of incidence, theta I, at which this k becomes 0, is known as the Brewster's angle. The next very important question from this topic here is on the Brewster's angle. Okay, it is the angle of incidence at which there is no reflection, at which there is no reflected wave, and उसके लिए क्या करना है, k को 0 करना है, and after solving k you get this formula. Okay, but usually when you get the question of k for people, when you get the question of Brewster's angle, you get this formula. When you get the question for Brewster's angle for for p polarization, parallel polarization, 99% expect that both the mediums will be having the same permeability, or both the mediums can be non-magnetic, such that after putting mu1 equal to mu2, you will have the formula. Forget sine square. Remember the easier formula, that is in the terms of tan square. So tan square theta b parallel, theta b p, is given by the formula epsilon 2 is divided by epsilon 1. Better remember in terms of tan square. This is how you can calculate the Brewster's angle. Very important. So tan square theta is given by the formula, theta matlab theta b actually, the Brewster's angle. So tan square theta b is given by the formula epsilon 2 by epsilon 1. That is the ratio of the permittivity of two mediums, and from this you can easily calculate the Brewster's angle, that is the theta b. यहाँ से आप Brewster's angle निकाल सकते हैं, right? Now if I talk about the S polarization, here also k has a subtraction in numerator, and you can choose a particular angle of incidence at which there is no reflection, right? That angle of incidence at which there is no reflection is the Brewster's angle. No need to repeat the definition, but what is the formula comes up here? Sine square theta b perpendicular, some complicated formula, but don't remember, just take it a guarantee from my side, insurance from my side, that if there is a Brewster's angle question for S polarization, right, you would be given epsilon 1 equal to epsilon 2, and so that you can directly use the formula again in form of tan square theta b is ratio of the permeabilities of the two medium here, mu2 by mu1. Now all this will be still unclear or still doubtful unless and until we take up a question. Now let's take up a question. Okay, Brewster's angle question will be separate. Let's first solve this question, and then we will take up the question on Brewster's angle separately. Uski hum baat kरेंगे, right? A uniform plane wave in air, with electric field given to you 8 cos omega t minus 4x minus 3z is incident on a dielectric slab. Z greater than 0. Dielectric slab is located for Z greater than 0, and there is the air for Z less than 0. Matlab there are two different mediums. There is a dielectric slab for Z greater than 0. The property of the slab are given to you, right? And the air properties we already know. Air properties means simply mu r equal to 1, epsilon r also equal to 1, and that is also a lossless medium, sigma equal to 0. फाइंड द प्रोपोगेशन वेक्टर ऑफ इंसिडेंट वेव, रिफ्लेक्टेड वेव, ट्रांसमिटेड वेव, सब निकाल लेंगे। एंगल ऑफ इंसिडेंस, रिफ्लेक्शन, ट्रांसमिशन, रिफ्लेक्शन एंड ट्रांसमिशन कोएफिशिएंट, रिफ्लेक्टेड एंड ट्रांसमिटेड इलेक्ट्रिक फील्ड्स। देखो, फर्स्ट आई विल एक्सप्लेन यू द एजेंडा ऑफ द क्वेश्चन, वेरी इंपॉर्टेंट। इफ दिस वन क्वेश्चन इज क्लियर ना, after that I will explain you Brewster's angle question, वो separate है, but other than Brewster's angle, all other concepts of oblique incidence will be clear to you. All other concepts. This one question has everything. Try to understand. I'll spend time on this question. This one single question has everything that you need. Okay, what is given to you, dear? Electric field of the incident wave. Electric field of the incident wave. What is given to you? Electric field of the incident wave. Let me explain you the picture first of all. Story क्या चल रहा है यहाँ पे? Let us understand this. Let us understand this picture slightly. Okay, so we have the incident electric field EI is equal to 8 cos omega t, 8 cos omega t minus 4x minus 3z, minus 4x minus 3z AY volt per meter. Full concentration. This is going to explain you all your concepts regarding to the oblique incidence. अब ध्यान देना. What is this? This is known as the Kx. What is this? This is known as the Kz. If I compare with the general form omega t minus Kxx minus Kyy minus Kzz, so I have Kx equal to 4, Kz equal to 3, there is no Ky. That means first of all, what is the propagation vector of this wave? I will call it as Ki, propagation vector of the incident wave. The propagation vector of the incident wave is, ये हो गया 4 times Ax plus 3 times Az. 4 times Ax plus 3 times Az. 4Ax plus 3Az. This is the propagation vector of the incident wave. Acha, that means when I am going to draw the picture, okay, the wave is traveling in the xz direction, combination of xz. So what is the axis I will choose here? What is the axis I am going to choose here? Definitely I am going to choose the xz axis. Let's say this is x, this is z. I am going to definitely choose the xz axis here. Okay. So what is my plane of incidence? Dear, what is my plane of incidence? My plane of incidence is xz. Right. And where is my electric field pointing? Electric field, the direction of electric field is AY, dear. Direction of electric field is AY. ये भी ठीक है. Right. So electric field is perpendicular to the xz plane. Perpendicular to xz plane. So what type of case is this? Perpendicular, or simply known as the S polarization. So this is the perpendicular or the S polarization case, dear students. This is known as the perpendicular or the S polarization case. ठीक है? Perpendicular or the S polarization case. Done. Okay, ये तो पता चल गया. It is perpendicular polarization and wave is traveling in a combination of xz direction. Achha. Okay. Now, very clearly mentioned that if this is the z axis, let's say this is z equal to 0. Z equal to 0 is the boundary. Because clearly mentioned that for z less than 0, you have the first medium which is known as air, and for z greater than 0, you have the second medium which is the dielectric slab. Dielectric slab, right? A portion of the wave will be reflected back, and a portion of the wave will be refracted, that is transmitted into the second medium. And we all know that the refracted wave is the one which bends in the direction. Okay. Now, this is what is known as the angle of incidence, theta I, because this is the propagation vector of the incident wave. This is the propagation vector Ki of the incident wave. This is the propagation vector Kr of the reflected wave, and this is the propagation vector Kt of the transmitted wave. Okay, so this will be theta I, then this is going to be theta r, and this is going to be the theta t. So sir, what is theta I? Can we calculate? Right. Okay. How do the wave? Right. Chalo. What is the theta I? So as I told you, the formula cos of theta I is ki dot an cap divided by modulus of ki. Now what is an cap? An cap is a unit vector normal to the boundary. So this is the vector normal, right? This is what is boundary. The xy plane is the boundary. Z equal to 0 matlab xy plane, and this is the vector normal to it. So when I want to write down the normal direction an cap, that is simply equal to the az. An cap is simply equal to the az. Just a second. Okay. So let me place down the values here. What should be the value of the ki? What should be the value of ki? Ki we have calculated 4ax plus 3az. Let us place down. What is cos theta I, dear? Cos theta I is equal to 4ax plus 3az dot product with az whole divided by modulus of ki, and modulus of the vector will be square root of 4 square plus 3 square. Z to Z component, x to Z will be 0. Z to Z component 3 divided by under root of 4 square plus 3 square, that is 5. So it is 3 by 5, okay, or 0.6. So what is going to be the theta I? Right, when you take the cos inverse of this, when you are going to take the cos inverse of that, you are approximately going to get this as 53.13 degree. Just एक बार check कर लीजिए. Approximately you will going to get that, right? Yeah, 53.13 degree. Perfect. This is the 53.13. चलो continue करते हैं, right? Okay. चलो, let us continue. Okay, just wait. I will take up your doubts. Let me continue because a very important and crucial question here. Theta I 53.13 degree आ गया, right? So what is going to be the theta r? Step by step. I know that theta I is 53.13 degree, right? So what is going to be theta r? We know that theta r and theta I are same. So that is again 53.13 degree. But what about theta t? Theta t के लिए I will go and apply what? Snell's law. Acha, let me tell you that you can also expect the question individually on the Snell's law. On the Snell's law, right? And Snell's law says that n1 sine theta I will be equal to the n2 sine theta t, right? n1, n is given by the formula root over of mu r1 epsilon r1. Acha, first medium to air hai na, refractive index of air is 1 into sine of 53.13 degree is equal to n2. n2 is root over of mu r2 epsilon r2 into sine theta t. यहाँ से solve करना है. Sine 53, cos 53 was 3 by 5. So this is going to become 4 by 5, and that is equal to root over. What is the parameters of the second medium? Dielectric slab. Mu r is 1 and epsilon r is 2.5. यहाँ लिख देता हूँ. Mu r equal to 1, epsilon r equal to 2.5. These were the properties given. यहाँ पे value को place कर देंगे. So this is going to be 1 is multiplied by 2.5 into sine of theta t. Into sine of theta t, right? So what should be the sine of theta t? Okay, that is 4 by 5. That is 0.8 divided by under root 2.5. Solve this value and get the answer. Everybody quickly solve this value and get the answer. Use only a virtual calculator. So this is 0.505 nearly. 0.505. So what is going to be the theta t? When I take the sine inverse of this, my answer is 30.39, or approximately, let me write this as 30.4 degree, or you can take 30 degree also, anything, right? So these are all the important angles measured. These are all the important angles measured, right? These are all the important angles measured, right? Correct. Plane of interface and plane of incidence. Can you little bit elaborate about plane of interface, Narid Banerjee? Can you slightly elaborate what exactly your doubt is? Maybe some mismatch of the words. ओके ठीक है चलो. Okay, now come to this theta I, theta R and theta T. That is what it is. ठीक है चलो check करते हैं अब आगे. So we are done with this. What is the angle of incidence, reflection, transmission? We are done. Right. What is the propagation vector of the given wave? We have done. Right. Reflection and transmission coefficient, reflected and transmitted electric field. Now what is the reflection and transmission coefficient? देखो, it is the what polarization? It is the S polarization. It is the perpendicular polarization, S polarization. Okay, so what are the formulas to be used? This is the S polarization formula, and I told you only calculate K. Tau will be 1 plus K, and K is given by the formula eta 2 with theta I, eta 2 cos theta I minus eta 1 cos theta T divided by the plus of that. Okay, divided by the plus of that. Okay, chalo, so let's calculate these values and talk about the reflection and transmission coefficient. Okay, so what is eta 1 now? Eta 1, the first medium is air. Yahi pe likh lete hain, it's better. What is eta 1? The first medium is air. For air, the intrinsic impedance is eta naught given by the formula 120 pi, or that is root over of mu naught by epsilon naught. Impedance formula already I have shown you, right? Right. Already I have shown you. Okay. Right. Chalo. Right. अब यहां पे आ जाते हैं. What should be the eta 2? Eta 2 is given by the formula root over of mu naught divided by 2.5 epsilon naught, root over mu by epsilon, root over mu naught by epsilon naught. Let this be eta naught only. So eta naught is divided by under root of 2.5. Eta naught divided by under root of 2.5, and that is 0.63. 0.63 eta naught, right? No, I don't think that's appropriate, Banerjee. Okay, but still, for your convenience, I will check it out. You can just put that on the Telegram as well. I don't think that is convenient. There can be a reflection direction. And if you talk about the reflection surface, it's going to be the similar plane, I believe, right? Okay. Now you want to specify now how it is the YZ plane. This is Z. And that is Y. How this is the reflection surface? Okay, according to this picture, if this is Z and this is Y, this is the XZ surface, right? This is the YZ surface. Sorry, you want to refer to YZ. And how this is the reflection surface? How this is the reflection surface? Okay. Chalo. So no, there isn't the consistency with the definition you are telling, Banerjee. Let's come here now. Let's complete the question now. Okay, now let us first complete this problem. So we have eta 1 is equal to eta naught, and we have the eta 2 is equal to 0.63 eta naught. And let us talk about the K, right? The Ks, or also known as the K perpendicular, and that is given by the formula eta 2 cos theta I minus eta 1 cos theta T divided by the eta 2 cos theta I plus eta 1 cos theta T. Correct? Acha ji. So let us just place down all the values we have calculated anyway. So this is 0.63 eta naught multiplied by cos of theta I. Theta I कितना निकाला था हमने? Theta I is 53 degree. 53.13 minus eta 1, which is eta naught, into cos theta T. Theta T transmission angle is 30.4. divided by 0.63 eta naught cos of 53.13 degree plus the eta naught cos of the 30.4 degree. Done? Acha ji. Right. So that is why eta naught can be common and cancel. Okay, let's place down the value. So this is 0.63, cos 53 was 0.6 minus eta naught to cancel ho gaya, cos 30.4. This is nearly 0.86 is divided by 0.63 into 0.6 plus 0.86. Let us complete this calculation, everybody. Right. Let us just complete this calculation. We have minus 0.389. Minus 0.389, or approximately write down minus 0.39. That itself is sufficient. minus 0.39. Correct? That is the reflection coefficient. So what is the value of K obtained here? Minus 0.39. This is one value done. So if I want to talk about the tau, is given by the formula 1 plus K, right? And when you add this becomes 0.61. So tau is given by the formula of 0.61, everybody. Okay? The tau is given by the formula 0.61. Now comes the main question. The main challenge. Now comes the main question and main challenge. What is the equation of reflected and transmitted electric fields? What is the equation of reflected and transmitted electric field? Electric field का equation क्या होगा? Reflected and transmitted electric field equation क्या होगा? Reflected and transmitted electric field equation क्या होगा? Now please everybody focus here. What is the incident electric field? The incident electric field is given in general by the formula E naught cos of omega t minus ki dot r ay volts per meter. So what is going to be reflected? What should be reflected? Let me write down this E naught as EI naught. Let's say the amplitude is EI naught, amplitude of the incident wave, which is given here 8 cos omega t minus something, that is given to us, but generally likh dete hain. Now similarly what should be the reflected? What should be the reflected field? What should be the reflected field? This is given by the formula ER naught cos of omega t minus kr. Which k? Kr. Kr dot r ay volts per meter. Okay, the direction of electric field always remains to be same only. And when I want to talk about the transmitted field ET. So what should be the ET, dear? Is given by ET naught cos of omega t minus kt dot r ay volts per meter. Now pay attention. Right. EI naught, ye to given hai. Look into the question. 8 cos omega t minus something. And we have also calculated this propagation vector of incident wave. 4ax plus 3az. This is what we already know. So similarly, to calculate the reflected and transmitted wave, पहले पूरा समझाता हूँ and then I'll give you the shortcut also. Then we'll talk about shortcut. What we need to know is ER naught and what we need to know ER naught and KR. What is the propagation vector of the reflected wave? What is ET naught? Amplitude of the transmitted electric field and propagation vector of the transmitted electric field. ये निकालना है. So number one objective, ER naught upon ET naught can be obtained by the K and tau formula, dear, because we have already calculated K and K has the definition ER naught divided by EI naught and K value is minus 0.39. So what should be the ER naught? It is minus 0.39 is multiplied by the EI naught. And what is EI naught? EI naught 8 tha. Right, it was equal to the 8. So this is going to be how much? This becomes 3.12. This is minus 3.12. Similarly, the tau perpendicular, okay, the tau is given by the definition ET naught upon EI naught, the ratio of the transmitted amplitude to the incident amplitude, and this is calculated as 0.61. So what should be the ET naught? This is 0.61 multiplied by 8.48. Another 8. 0.488. Oh, sorry, it should be 4.88. 0.61 into 8. This is 4.88. Ye bhi done ho gaya. So we know ER naught and ET naught. What is the only thing unknown now? What is the only thing unknown? KR and KT. I'll explain you this. This requires some geometrical calculation. And guys, don't think that this is a lengthy problem. No. Within this problem, we are covering several things. Snell's law bhi cover hua. And these are all individual questions in exam. Snell's law or the angle of reflection, angle of transmission, or you can call the, the KR and KT, the propagation vector of reflected transmitted wave, or the k and tau that we have calculated. Either k is a question or tau is a question. All these are individual question. Combining so many things, we have a bigger question which is explaining you everything. If you're understanding, do not forget to like the session. Keep liking the session. And now let's focus on the KR and KT. For that KR and KT, let's hit on the geometry. Okay, पूरा इसको geometry से समझ लेंगे. That's going to make that easy for you. That's going to make that easy. Okay, let me draw that picture here and everybody please understand. Okay. Now, dear, pay attention. This is the Ki. This is the Ki, propagation vector of the incident wave. This propagation vector, let us use the resolution of the vector. This propagation vector can be resolved into a horizontal component and a vertical component. Acha, what are these directions? We already know this is the Z direction. Just a second. The EMT class, Manju. Yeah. So this is the Z direction and this is the X direction. So this can be resolved into a horizontal direction which is known as KIZ, and this is KIX. Already we know KI, but just I will first apply the resolution on KI so that you can get the KR and KT. Dhyan dena. So dear, how much is this angle? This angle is the theta I. Okay, so this is the alternate angle. These two lines are parallel. Both are towards the Z axis. These are parallel lines, and according to alternate angle, this will also be theta I. Theta I bole to kitna? 53 degree. So what should be the KIZ? Dear, what is the KIZ? What is the horizontal component of the any vector when you are resolving it? KIZ is given by mod KI into cosine of theta I. Cosine of theta I. अब ध्यान देना यहाँ पे everybody. What is the Ki? Ki is actually already calculated. Okay, but just I want to show you the resolution wala case and then I will come back to the KR and KT. So what is the modulus of this vector? What is the modulus? This is given by square root of 4 square plus 3 square and that is equal to the 5. That is equal to the 5. तो यहाँ पे कितना आ जाएगा? This is equal to 5 cos of 53 degree, which is 3 by 5, and this is equal to 3. Z component should be 3. Similarly, if I want to calculate KIX, what is the X component of this vector? What should be the X component of this vector? It is given by mod KI. The vertical component is given by the sine theta formula, mod F sine theta. Mod F sine theta. Right. So modulus already we know, modulus equal to 5. Sine of 53 you calculate will be 4 by 5 and this comes out to be 4. Right. So X component should be 4. That means if I want to write down the K vector, X component should be 4, 4AX, and Z component should be the 3, 3AZ. Correct hai kya? Is this the information you already know? Yes guys, this is the information we already know. KI is 4AX plus 3AZ. 4AX plus 3AZ. Done? Right. So if this idea is applicable on KI, let us use this idea to calculate KR and KT. Problem will be solved after that. Okay, problem will be solved after that. So dekhenge yahan pe. Okay, let us just see here. Right. Let us just see here. So this is the KR. Okay. This is the propagation direction of the reflected wave, but KR is unknown to me. Again, I will resolve it. Into a horizontal component and a vertical component. Very clearly, its horizontal component is going along the minus Z direction. Okay, let me call this as KRZ, let me call this as KRX, and let me calculate the numbers here. Everybody, what should be, I hope this is visible to all of you, right? What should be the value of KRZ, horizontal wala? Mod KR cos theta. Which theta? Now angle bana dete hain. This is the angle of reflection theta r, right? This is z axis, this is z axis, both are z axis, parallel lines. So this is the corresponding angle. So this is also theta r, right? This is also theta r, and theta r and theta I are same. Theta r and theta I are same. So theta r is also 53.13 degree. तो KRZ कितना हो गया? KRZ is equal to mod KR. Now what is mod KR? I told you one more thing, that modulus of K is equal to beta. What is the magnitude of propagation vector? That is equal to beta. That means if I want to talk about modulus of Ki, where is the incident wave? Incident wave is in the medium number 1. Incident wave is in medium number 1. ठीक है? What about reflected wave? Reflected wave reflects back into the same medium, na? So reflected wave is also in the medium number 1. Reflected wave is also in the medium number 1. So that will also satisfy the beta 1. Okay, that will also satisfy the beta 1. That means modulus of Kr will be simply modulus of Ki, and that is known to us. That is 5. Modulus of Ki to 5 hai. Okay, so I will place this value here. 5 cos 53 degree, 3 by 5. So this is 3. And similarly, Krx nikal lenge. Right, what is Krx? That will be mod Kr into sine theta r. Place down the value. Magnitude is 5. Sine of 53 degree, same value, 4 by 5. So this is going to be 4. So dear, you get your answer here. What is Kr? What is Kr? Dear, what should be the Kr? Okay, x component is 4. So 4ax. Z component 3 to hai. But very clearly, Z component 3, but it is pointing in the minus Z direction. This is the plus Z. So Z component is going in the minus Z direction. So I will write down minus 3az. I will write down the minus 3az. 4ax minus 3az. 4ax minus 3az. Okay. Similarly, quickly guys, let us come here. This is the propagation vector of the transmitted wave KT, and I can also resolve this into the horizontal component and the vertical component. This is the angle of transmission already calculated using the Snell's law. Ye theta t ho gaya. This is a line parallel to z axis, so this is the corresponding angle. Ye bhi theta t ho gaya. Theta t we know is 30.4 degree. It is a 30.4 degree. So guys, what is the, this is known as KTZ, Z component, horizontal component, and this is the KTX. So everybody, what is going to be the value of the KTZ horizontal component? It is mod KT cos theta t. Mod KT cos theta t. But dear, what is the mod KT? Right? What is going to be the mod KT? Mod KR and mod KI are same. But what is mod KT? The transmitted wave is in the second medium now. Transmitted wave travels forward, that is in the second medium. So mod of KT is the beta of the second medium, that is beta 2. That is a different value, right? So अब यहाँ पे ध्यान देंगे. Modulus of Ki, again, modulus of Ki is beta 1, and beta 1 is given by the formula omega root over mu epsilon. For the medium one, mu is mu naught, epsilon is epsilon naught, because it is the free space. It is the air actually, right? Beta 2 is omega root over mu ki jagah mu naught, mu r is 1, epsilon is 2.5 epsilon naught. For the second medium, you can check the relative permittivity, that is 2.5. Okay, so when I divide them, na, mod KT divided by 5, mod KI ka value 5 hai, will be equal to omega cancel, mu naught cancel, right? Epsilon naught cancel, only root 2.5 will be left. So what is the value of mod KT? It is 5 into under root of 2.5, and let me figure out how much is this value turning up. How much is this value turning up? This is 7.9. So modulus of KT is turning out to be 7.9. Okay, so modulus of KT you have to calculate separately by putting the formula that mod K is equal to beta. Just a second. Mod K is equal to the beta. Done hai? Acha ji. So I will place down the values here, right? This is equal to 7.9 into cos of 30.4 degree. Calculate this value and write down the final answer. And this is 6.81, approximately 6.8 लिख देते हैं. And then the next thing that I need is the KTX. vertical component, and that is given by mod k into sine theta t. Mod k 7.9 into sine of 30.4 into sine of 30.4. This is 3.997, which is approximately 4. Right, if you use the exact value, this 7.9 is also approximately, 30.4 was also approximation. If you use the exact values, this is going to be exact 4. Okay, this is going to be exact 4. Okay, so right now also approximately 4 has come, not an issue, right? So this is 4. So what is going to be the KT? What is going to be the KT? In the x direction, it is 4ax, and it is clearly positive x and positive z, both are positive. So z component आया 6.8, so plus 6.8 AZ, right? Plus 6.8 AZ. This is what is the KT. I will just substitute and my answers are finished then. Okay, right? So what is the expression for ER? ER is given by the formula ER naught cos omega t minus KR dot R, correct? AY volts per meter. That is just the expression I've explained you. This is what I wanted. Okay. This is what I wanted. Ye ER ho gaya. Okay. So time to write down the final formula. Answer. ER, reflected electric field, is, this is obtained as minus 3.12 cosine of omega t minus KR dot R करेंगे तो minus 4x and minus minus plus हो जाएगा. तो minus of 4x plus of 3z AY volts per meter. This is one of your answers. Right. Similarly, if I want to write down the ET, ET is given by the formula ET naught cos omega t minus KT dot R AY volts per meter. AY volts per meter, right? So what is going to be the calculations? We'll just put down, and the answer for ET, this is ET naught 4.88 cos of omega t minus KT, so 4x and 6.8z minus 4x minus 6.8z AY volts per meter, and this is the final answer for ET. These are two very important and crucial calculations. Now a very quick observation, now a very important observation, okay, that is going to help you in many of the MCQ questions. This is the given electric field. Everybody see, this is the given electric field. Then this is the ER. Then this is the ET. This is the ET. Now, if you have a note, where is the boundary? In this problem, boundary is given by z equal to 0. In this particular question, the boundary is given by z equal to 0. So, what is the vector normal to the boundary? What is the normal direction? The normal direction AN is given by AZ. The normal direction AN is given by the AZ. The normal direction AN is given by the AZ. It is given by the AZ. Okay? The normal direction AN is given by AZ. Ab dekho, since the normal direction is AZ, look into the changes. Incident and reflected, what is the only change? Only there is a sign change of the Z component. Only and only there is a sign change of the Z component. Dhyan dena. Only and only there is a sign change of the Z component. Is that clear, everybody? Then incident and transmitted wave comparison. Incident and transmitted wave comparison. It is minus 3z, so it is minus z only. There is no sign change, but there is the coefficient change. 3 ki jagah there is some other coefficient. there is some other coefficient. There is some other coefficient, right? So this is only sign change. Only sign change in the Z term, and here, right, only magnitude change of the Z term. Only magnitude change in the Z term. Only there is the magnitude change in the Z term, but if you talk about the X component, that is entirely same. That is entirely same, isn't it? Right? There is no change, neither the sign, neither the magnitude. There is no change in the X term. Right, minus 4x, minus 4x, minus 4x. So there is only going to be change in the term corresponding to the normal direction. Clear? Right. If it is reflected wave, only sign change. If it is transmitted wave, only magnitude change. This can help you satisfy options, MCQ based option. Trust me, when you solve the PYQs, this property can help you solve even the 2-marker PYQs just by observation. Just by observation. Right? Just by observations. Just by the observations. Okay? This can be really helpful for the MCQ or MSQ questions. By observation, you can comment on the answer. Only by the observation, you can comment on the answer. Okay? Only by the observation, you can comment on the answer. So, yeah, let us come here. A uniform plane wave traveling in free space and having the electric field, having the electric field is incident. Having the electric field is incident on a dielectric medium. Okay, first it is traveling in free space and it is incident on a dielectric medium whose relative permittivity is greater than 1, but the relative permeability mu r is equal to 1. And this is the shown picture, and there is no reflected wave. Very, very important condition of the question, that there is no reflected wave. Incident electric field expression is given to you. What is the relative permittivity of the dielectric medium? There is no reflected wave. Is picture mein the question is, what is the epsilon r? What is the relative permittivity of the dielectric medium? What is the epsilon r? And there is no reflected wave. Guys, what is the condition for no reflected wave? No reflected wave is the case for Brewster's angle. There is no reflected wave if the angle of incidence is equal to the Brewster's angle. If the angle of incidence, I think again some issue, voice issue, but it will get rectified in few seconds, don't worry. So this is related to what? This is related to the Brewster's angle. This is related to Brewster's angle. There is no reflected wave. Brewster's angle has to be used here. This is related to Brewster's angle. There is no reflected wave. Wait, I think some noise is there. Let me just check that once again. Okay. Okay. There is no reflected wave. Brewster's angle. That means the wave should be incident at an angle which is equal to theta b. The angle of incidence should be theta b. Right. तो ये जो angle of incidence यहाँ पे दिख रहा है, this theta I, this should be equal to the Brewster's angle. Okay. Now, what is the theta I? Given this E, what is this? Some amplitude root 2 ex minus root 2 ex minus az डायरेक्शन भी आ गया यहाँ पे cos of omega t minus 2 pi x plus root 2z. यहीं से सॉल्व कर लेते हैं. What is this? Omega t minus kx into x. What is the kx? What is the kx? It is 2 pi. Right. Minus kz. Minus kz. 2 root 2 pi z. 2 pi into root 2. So what is the ki? What is the propagation vector of the incident wave? Right. Kx है 2 pi and kz है 2 root 2 pi. 2 root 2 pi az. This is the ki. This is the ki. So according to us, what should be the angle of incidence? Everybody. What is the angle of incidence? We know the formula for angle of incidence. Cos theta I. It is given by the formula ki dot an cap divided by modulus of ki. right? What is A n cap? What is unit vector normal to the boundary? Very clearly seen, this is the boundary. And what is the unit vector normal to the boundary? It is x. This is clearly normal to the boundary, and that is along x. That is along the x direction. It's very seen in the, obviously seen in the picture, that is along the x direction. Okay, so यहाँ पे value को put कर देंगे. We have 2 pi को common ही लेके चलते हैं. So we have ax plus root 2 az dot product with ax divided by the magnitude of this vector. तो 2 pi तो common ही रहेगा. Magnitude of ax plus root 2x, so square root of 1 square plus root 2 square, right? X dot x will be multiplied and equal to 1. So you will have 2 pi divided by 2 pi under root of 1 plus 2, that is 3. 2 pi cancel, 1 by root 3. So dear, cos of theta I is 1 by root 3. 1 by root 3. So what is theta I? What is going to be the theta I? So from here we can calculate the angle of incidence. So this is just like the previous question calculation. वो निकाल लिया है. This is 54.74 degree. How much, dear? This is known as the 54.74 degree. This is known as the 54.74 degree. But we know that for no reflection, the angle of incidence should be, the wave should be incident at Brewster's angle. Now, what is the formula for Brewster's angle? See, here, for the second medium, mu r equal to 1. Clearly bola. And the first medium is anyways free space. So there also mu r is 1. Okay. So what I can clearly say, mu r1 be 1 hai and mu r2 is also 1. So clearly mu1 is equal to mu2 case hai. So that is why the Brewster's angle formula, right, tan square theta b will be epsilon 2 by epsilon 1. That is the formula you can use. अच्छा, एक और चीज यहां पे देख सकते हैं, right? What is the plane of incidence? XZ. Hey, what is the plane of incidence? Let me mention that point first of all. What is the plane of incidence? Clear observation. Because here the last question we have drawn the diagram. We drew the diagram. Here it is given plane of incidence is XZ. Plane of incidence is XZ, right? And where is the electric field pointing in this question? Everybody please see the direction of electric field. Everybody please see the direction of electric field. Electric field also has two components. One is the X, one is the Z. The electric field is also in the XZ direction, right? It has two components. One is in the X, one is in the Z, but both are in the plane of incidence. Both are in the plane of incidence. So this is known as what case? The electric field is parallel to the plane of incidence. This is the parallel polarization. Everybody, parallel also known as the P. This is the parallel polarization. Parallel polarization. And furthermore, I was just telling you that mu1 is equal to mu2. That is what I have just shown you. So what is the formula that you are going to use for the Brewster's angle? Tan square theta B is epsilon 2 by epsilon 1. Tan square theta B is epsilon 2 by epsilon 1. Right? Okay. Chalo. Undoubtedly, Divyansh, if you want the complete comprehensive course, it's BYJU'S with all best faculties, best study notes, workbooks, PYQs, everything is given. Test series, everything. So tan square theta b, what is tan square? Acha, then no need to calculate theta I. है ना, इसको निकालने का निकाल लिया, that is okay. Okay, but tan square theta, why you don't need to calculate? Tan square theta is also given by the formula sec square theta. अच्छा, what is theta b? That is theta I actually. ये लिख देते हैं. Theta b will be theta I, right? So we have tan square theta b or tan square theta I, which is sec square theta I minus 1, because sec square theta is 1 plus tan square theta. It is 1 plus tan square theta. And sec square theta कितना होगा? Reciprocal of cos, and that is 3 minus 1. So this is 2. Okay. So we have tan square theta is 2, and that should be epsilon 2 by epsilon 1. What is epsilon 2? It is 2 epsilon 1. What is epsilon 1? The first medium is free space. The first medium is free space, that is why the permittivity is epsilon naught. So epsilon 2 is actually written as epsilon r epsilon naught. So here by comparing, I can say that epsilon r is equal to 2. It's a good question in GATE for 2 marks related to the Brewster's angle. The relative permittivity of the medium is equal to 2. the relative permittivity of the medium is equal to 2. The relative permittivity of the medium is equal to 2. Correct hai? This is equal to 2. Everybody done. Relative permittivity is equal to 2. Cool. That's it. Done hai? Right. Chalo guys. Okay. So I hope this question also gives you some good learning here. Okay. Chalo. Done. This is done. Yeah. Right. So guys, yes, the time is very close. GATE exam is very close. Still, if you are not appearing in test series, right, and if you want separate test series of BYJU'S exam prep, which will give you unlimited access to subject-wise test as well as full mock test, you can just enroll to the GATE and ECE test series, whose link is in the description of the video. You can refer to the details of this, right? And yes, this test series, 60 plus test covering GATE and ECE, both GATE test alag, separate test for ECE, detailed analysis of the mock test, virtual scientific calculator so that you practice as per the GATE demands, right? And it has been made and curated by GATE experts. All India open marks are also there, and 4,000 plus practice questions will be there, comprising all questions of test series. So you can utilize this, and that's it for the session, guys. Okay, I hope you have got your fundas and concept. This was a brief session. There can be many more questions on oblique incidence, but yeah, in this brief session, almost 1.5 hours, we have covered up the concepts and the methods to solve the deal with oblique incidence. Hope you have got the clarity. Next, you can practice. So tomorrow at the same time, 9 p.m, we are going to deal with the questions on transmission lines. Questions on the transmission lines. Chalo, yes, aaj ka password. So password, let the password be angle. Let the password be angle. Some random password today, angle. Okay. Yesterday's PDF is also due. I will share both the PDFs together. Okay. Yesterday PDF was also due. I will share both. Maxwell's equation. Right. Tomorrow we'll study transmission line at the same time, 9 p.m. Bye bye. Next week after EMFT, there will be the communication classes only in this crash course, Rohit. Okay. Bye bye. Thank you. Stay safe and take care of yourself.